Modern web applications process massive data flows and deliver deeply complex, multi-layered interfaces. Yet structurally, they all collapse into a single flat plane. Unlike traditional websites that request a new document from a server every time you click a link, modern architecture relies on the single-page application. The browser loads exactly one document, and everything else happens within it. This creates a functional gap. Web browsers natively execute static HTML, standard CSS, and vanilla JavaScript. They lack an internal engine designed to parse React components. This diagram illustrates the core constraint. On one side, the dynamic internal logic of a JavaScript framework. On the other, the browser's rigid document object model, or DOM. To function, it must bridge this gap, a mechanical process carried out by the JavaScript execution layer. To see exactly how a React application gets onto your screen, we have to map its rendering pipeline, the specific path it takes to inject itself into a static file. React functions as a highly optimized DOM manipulation engine, mapping its complex output onto a static architectural bedrock. We start at the absolute lowest level of the architecture. This is index.html. It serves as the sole entry point and bedrock for everything that follows. Near the top, the file includes a no-script tag. It exists purely as a fallback, explicitly telling users they must enable JavaScript for the application to run. But the actual body tag of this document is almost entirely empty. It contains 0 content, 0 images, and 0 interface elements. It holds only this. This specific div, assigned the ID of root, is the foundational anchor point for the framework engine. JavaScript cannot manipulate a web page unless it has a specific node to attach to. This explicit empty div provides exactly that target. Whether a React app has 3 buttons or 3,000 complex UI components, every single element originates from and mounts directly inside this empty div. If the HTML body is completely devoid of content or scripts, how does the browser actually know to execute the React engine? Here is a comparison of 2 build environments. On the left, the legacy approach popularized by Create React App and Webpack. On the right, modern tooling using Vite. The legacy approach relies on abstraction. When you build the project, tools silently inject execution scripts into the HTML file, entirely behind the scenes. You cannot find this script in your actual source code. A developer has to open the browser's inspection tools to realize that a massive bundle.js file is doing the heavy lifting. Modern environments like Vite reject this hidden layer. Instead of concealing the execution, Vite explicitly declares the main JavaScript module directly inside the HTML source file. This distinction dictates the developer's mental model. One hides the injection point, while the other shows exactly where the static file summons the logic. Exposing the injection script removes technical ambiguity, revealing the application's actual architecture. Moving one step up the pipeline, we arrive at the primary execution file, main.jsx. Before React does anything, the script uses standard vanilla JavaScript to select and extract the HTML node we just saw in our index document. This is the exact moment of handoff. The script takes a native browser node and passes control of it over to the framework. It invokes React DOM.createRoot, an initialization function that fires up the React engine and tells it where to build. Using this single anchor, React immediately generates a completely parallel, mirrored structure in the browser's memory. This is the virtual DOM. Updating the actual browser window is computationally expensive. The virtual DOM solves this by acting as a lightweight sandbox. It establishes a controlled shadow environment where the engine computes visual changes, compares them to the current state, and applies only the strict minimum of necessary updates to the real DOM. The engine requires instructions to populate that shadow environment. It receives them through JSX components. JSX is an extension that allows developers to write familiar HTML-like syntax directly inside JavaScript functions, but the parser enforces strict contracts. The first contract is the capitalization rule. If a component is named in lowercase, the build fails. When capitalized, the parser approves it. The engine uses this rule to instantly differentiate between a native browser tag, like an h1 or div, and a custom function built by developers. The The second contract is the single parent rule. A component must return one and only one single top-level element. Returning multiple sibling elements side by side breaks the strict hierarchy of the tree logic. The parser cannot map two independent roots into a single continuous branch. To solve this, developers wrap siblings in an empty tag called a React fragment. It groups the elements for the parser without adding unnecessary markup to the final web page. These syntax requirements are not arbitrary stylistic choices. They are rigid parser contracts required to maintain the structural integrity of the virtual DOM. Now, let's review the complete rendering pipeline. We begin with the static index.html document. Inside it, a script tag explicitly injects main.jsx. That script extracts the empty root div, hands it to React to generate the virtual DOM, and passes in the correctly formatted JSX payload to render the final user interface. This recontextualizes what happens when a user navigates a single-page application. As you click a button to view an About page or select a new item from a menu, the URL bar changes, but you are never requesting a new HTML page from a server. Look back up the pipeline. The original foundation, the index.html file and its empty root div, remains entirely static. Navigation in these environments is the React engine unmounting one JavaScript payload and mounting another onto that same anchor point. By mapping this rigid injection pipeline, the complexity of React resolves into a predictable, logical sequence of DOM manipulations.